Today we are going to go and talk about soft lithography. I guess you guys only had 2 weeks of lecture, so you probably don't have too much backgrounds on kind of manufacturing. Like, you guys all get on one side. I don't really, like, work out my neck a little too much here, but thank you. So basically, as you're gonna like kind of learn throughout the week with all these practicums, you're doing what's it called, clean room, you're doing the rapid tech. These are all different like advanced so-called manufacturing techniques. Today we're kind of going over what is soft lithography. And so to understand that, from what I understand, you guys didn't even cover photolithography yet. So in general, do you know what the term lithography means at all? Anybody? Volunteers? Raise hands. No? So in the easiest term, lithography will be just a stencil, and you just cut using the stencils essentially. You have a mask of some kind, and then you apply some kind of solution, and you're etching away, and you're making a pattern with that mask. So in the case of photolithography, which I'm sure you're going to learn in the class, you're utilizing light in this case that goes through the mask, and then you either cross-link or remove bonds in the polymers, and then once you use a solvent, you wash away, you get a pattern, and then you can do whatever you want with that pattern. In our case, soft lithography kind of implies what it is as well. You're using a soft kind of this, what do you call it? I'll pass this around. This is a PDMS after it's been cross-linked. And you guys can like play around, bounce it, I don't know. But it's perfectly safe, biocompatible. That's one of its many benefits and why people use it. But kind of play around with it. You can see it's kind of jello-y polymer. But basically the idea is you have this soft polymer that you flow over a mask, or even like stamp, for example. You have a mask and you stamp it onto this soft polymer. It could be clay, it could be kind of like putty kind of thing. But the idea is you have a mask that you imprint on top of your little polymer or some kind of substrate you want, cross-link it, harden it. Now you have the mold or the imprint of your mask on top of it. And then once again, proceed to your next step, whatever that may be, So today, what we're going to specifically use is PDMS. So as you guys can see, when you're playing around with that little block there, well, actually, first, can anyone, after seeing that, guess what that imprint is? Yeah, exactly. So from a previous class, it has a recycle sign on the bottom of it. Basically, it flows in the cracks and takes whatever shape it does. And so today, we're going to have these samples, what looks like kind of like crop circles on these little silicon wafers. Be careful with them, they're fragile. So once you guys pass them around, unfortunately we only have 4 of them. So you guys are gonna have to kind of work in groups, as ridiculous as that may sound, because the process isn't that difficult, but try to get your hands on it as much as you can, get an idea of what you're doing. But why don't we just kind of break up you guys into groups right now. So that's your groups. I'm gonna go ahead and pass out one of these for each of the groups. So here you go. So I kind of said most of these patterns may seem kind of like nonsense to you guys, because it just looks like little circles and like squiggly lines. But most of these are actually modes for what we do in this lab, CD microfluidics. So CD microfluidics is essentially using the CD's platform ability of like spinning centrifuge, use the centrifuge force to pump your fluids through the chamber. So some of you guys can see like little channels, right? And they're usually kind of like flowing outward towards the outer radius. So that's basically how the kind of pumping mechanism works, right? It pumps from the inner radius to the outer radius using that force. And then you can design in however many patterns to do whatever kind of like fluidic system you want to do. So today we're going to use that mode, which uses a silicon wafer as the base with what they call SUA photoresist that utilize what I mentioned earlier about the photolithography, and create a pattern on there which we're going to use as the mode. So at this point, I know I went probably kind of fast because we kind of have to do this quickly, but any questions about anything I've said so far?
So it's for etching more, right?
Well, yeah, etching, it's more or less pattern making, essentially. Like, is it? Surface. Yeah, so in this case, you're not really etching, right? You're just kind of like pushing it down and moving it past. You're not actually like physically removing any parts from the PDMS. The PDMS just forms around it, you peel it off, and there's your pattern, right? So yeah, you're forming these patterns in lithography. The photolithography, you would dissolve away the parts that aren't cross-linked, for example, right? So I kind of said etching, but you know that's just removing parts. You're basically making patterns with whatever your mask is. Okay, so kind of clear. All right, so I'm gonna go ahead. Can I have like one volunteer to kind of demonstrate the whole process of soft lithography? Anybody interested? No? Sure, go ahead, come here. So the process is actually extremely simple. For the purpose of this lab, what you're gonna do is you're gonna take one of these cups and you're gonna place it on this, what is it called, scale, and you're gonna tear it, and just like what she did. And what you're gonna do is then you're gonna take this base, which is the PDMS base, and you're gonna pour it out. And you can pour anywhere between 40 to 50 grams of this. That way it should be enough to cover the surface of that so you can get a good mold and that you can peel off later. And then we're gonna mix then 10-to-1 ratio in favor of the base of the curing agent, which will cross-link your PDMS. And so the reason, for this specific soft lithography, there's no really reason why we're using 10-to-1 ratio. For us, it's just for the purpose of demonstration. But depending on your curing agent, depending on your, how you let it cross-link. For example, we're using an 85 degrees C hot plate in like 3 different locations where you will be resting your mold on in order to harden this much more quickly. But yeah, depending on all these parameters you kind of play around with, you can either get something like this, which is very pliable, or you can get much stiffer structures. So today, this is kind of the result you're going to end up expecting to get. That way you can kind of peel it off your mold, and you can cut out the little pieces. And then, and I really don't see any problems. If you want to take it home, go ahead and take it home. There's a little rubber thing you can play around with. Go ahead and let's see which one's already opened. Okay, they're all open. Okay, all right. So actually, why don't you get where to cut the gloves? All right, so you want extra small or small? Okay. There you go. So get some gloves on. This material is very viscous, very sticky, so you kind of don't want to get it on your hands. And actually, just for the sake of safety, we're going to go ahead and wear these safety glasses. You really shouldn't be pouring this out so fast that it's going to splash everywhere, and it's kind of hard to do that in the first place. But just for your own safety, please wear proper eye gear. So go ahead and pour out the 40 grams of it, and then we're gonna go ahead. And so while she's doing that, the next step we're gonna do is take these little pipetters, and you're gonna kind of pipette out the curing agent, and then just gonna add onto it until you have the 5-to-1 ratio. So if you do 40 grams, for example, you're gonna add 4 more grams, so you get 44 total. Right, simple math. So you don't have to tear it if you don't want to, but that's kind of the first process. So go ahead and use that stir tip, and then stir it.
Excuse me, I'm not really clear on the ratio. Can you repeat it again?
It's 10-to-1.
10-to-1? Okay.
So, well, I guess 10-to-1, 9-to-1, roughly like 4. I mean, it'd be, obviously when you do 10-to-1 is total, so you actually do like 1-11. But like roughly there, it doesn't really matter like today because we're not going to be that precise. Like if we really wanted to make very good fine microfluidics chambers, we'll be doing it in a clean room as well, just to make sure there's no dirt or any particles that can mess up your little tiny chambers. But for today, like roughly around there is fine. So you don't have to be too precise with that. So go ahead. Right now, what we're going to do is each group is going to go ahead and mix their parts. And then once you finish pipetting out, use that a little pipetter and stir it vigorously for a good minute or two. And once we're done with that, we're going to take it to the next step, which is the vacuum chamber. So why don't you guys go ahead and just get that done, and I'll explain the next step of the process.
What's the cure time? What's the cure time?
Curing temperature?
Like cure time, like
Cure time?
after you like put the
Well, when we put it at 85 degrees C, it's going to be about 10 minutes. For this one, without 10 minutes, I actually don't know the exact time. It takes a much longer time. So,
so if you don't heat it up, it will take more time.
yeah, like for example, that little ball has been in there for like a day. So, you know, that's like how slow it could potentially take up to. But
I have a whole sweater too. Huh? I have a whole sweater too. Oh, yeah? My looking makes it.
okay. So this here is our like simple little vacuum chamber, right? So what you're guys gonna go ahead and stick this in here, your cups. Let's just put this upright for the demonstration. And we're gonna do is just turn this vacuum on, and you can see it starts to suck down, right? And so the vacuum's on, it's sucking pretty tight. So the whole purpose of this is, as you can see, the three groups that are currently stirring it, there's a lot of bubbles in the PDMS, right? So what's that? So can anyone tell me, like, just straight up logic, what would that happen if you have a lot of bubbles in your PDMS and you're trying to make a mold?
It will still be there.
It will still be there, exactly. So if you're trying to make very fine, like little tiny features, or you know, for your channel, and you have suddenly a lot of bubble, that feature just got a lot bigger, right? So the whole goal of this is to remove those bubbles and just basically suck them out. So that's what we're going to be doing here. Normally, the best procedure would actually be to pour that onto your mold first and then suck it out before you go to the next step. Unfortunately, this thing can only fit your 4 cups, and if we did the mask individually, it will take like one at a time. It might take too long. So we're gonna go ahead and just remove the bubbles from there. So when you guys go ahead and pour onto the mask, just make sure you do it nice and slowly, so you do not introduce any additional bubbles to your mold that can mess up your features. Okay. So and then the final thing is, when you guys take it out, be very careful, because there's no real exhaust on this thing. So the only real way to pull it out is to pull this out. So if you pull it out too quickly, that thing flies, and you're gonna have your like PDMS all over the place. So when you pull it out, do it very gently. Just like let it squeeze out. Like if you just shook this up and this is like a 7-Up ready to explode, you're gonna like let it out little by little, right? You're not gonna go ahead and just let it explode. I mean, maybe if you're doing a celebration, but we're not that happy right now. So, all right. So the people that's been like mixing for a while, first 2 groups, why don't you guys go ahead and put it in and start the vacuum. The next 2 groups, let's wait maybe another 2 minutes for the last group to finish stirring it, and then we'll do that for them as well. And then finally, go ahead and after this, you can go ahead and pour it onto your mold and set it onto one of these open hot plates. There's 3 of them, so two of you guys will have to share it on the back one, which is the biggest one, okay? Oh, watch it. Yeah, you gotta make sure these O-ring stays inside. So, otherwise it's not going to vacuum very well. Okay?
This is closed.
Yeah, just push it in as much as you can. The vacuum will pretty much take care of the rest. You can go ahead and keep it open, because the vacuum, what it does is sucking it through that. So, yeah.
So now turn it on?
Yeah, go ahead and watch. You can watch it kind of suck down a little bit.
I've done it with like.
All right, and then I'll just be careful. All right, so it should be fine.
And these polymer.
So,
Open it like this one?
yeah. Basically, you know, it's just sucking the air out of it. So go ahead and just look at it when it's like much clearer. Then you guys can let me know. Maybe I'll just let it out for you guys. So just talk with somebody who does this a lot. If we just did this method, the problem is it will take hours for the bubbles to pop. So apparently there's actually a trick to it. And the trick is we're gonna go ahead and turn this off every minute or so. And we're gonna do it the slow way. We're gonna slowly open this and then let it out little by little. And this will actually help pop the bubbles that are on the surface that you can see that's really foamy and frothy. And then that will, yeah boy. Yeah, you can go ahead and like kind of hear it a little bit. And then basically this will help kind of, or apparently this will help, what's it called, remove a lot of the bubbles. So you just do this every so often, and then you should be able to get this or every minute or so, and it should be fine. So as you can maybe like hear right now a little bit, probably not, but you can hear the air kind of like flowing in. As long as what's it called, the speed is not high enough, then it will not like, you know, push it up, obviously. So alright, so we're gonna go ahead and do this a couple more times. So, do I have any brave volunteers that would risk knocking over 4 cups to do this every so often? And then maybe we'll rotate off. Anybody?
Should I do this?
Yeah, why don't you give it a shot?
Turn the vacuum off first? Is that
Yeah. So be careful.
Sort of wiggle it?
Just like kind of twist it, wriggle it. It'll like loosen it up a little bit. You can hear, right? A little bit of gas coming out.
Occasionally someone will mess up and pull it off and go.
Yeah. I mean, you just gotta hope it doesn't like, cause like before when I was first trying it, I just like straight up pulled it off. That thing like just flew like everywhere. This demonstration, it just went up and then like went back down. So I don't know.
I hear gas.
Yeah, you can hear it.
Should keep coming out.
Yeah, I hear it. So just like hold on it a little bit. Like look at the gauge on the like just the cups, like how much they're wiggling. Like for example, when I was doing it before, this cup was empty. When you're pulling at that, you can kind of actually see the cup shaking. So if they're not shaking that much, you can probably pull it out just a little bit more. It's like, you know, just test the water like that. So basically, it's kind of like depends on the person. You like he couldn't hear the little hissing sound, right? Yeah. So what I was telling him, the best way to gauge is just look at the motion of the cups, pull it out like maybe like millimeter by millimeter. Oh. If you don't see like it moving too quickly or too much, then you can probably like pull it out a little bit more. Right. If it was shaking a lot, maybe leave it there until it like stabilizes and then you take it out. So that's the best way to go.
This one, right? No.
This one right here. This one, leave alone, is this part right here.
Oh, okay. I see.
So, but yeah, you still got like another minute. So go ahead and relax. And we'll start in like 4:16, okay? So yeah, you can see like a lot of bubbles are coming out right now, right? Yep. So what actually happened was like before, like when we took it off, you can see like it's like a lot less, right? So I think it's a mixture of it's like the initial tug on it is like stronger than the continuous almost. So that's why you kind of like stop, go. That's at least my little theory about it. But I don't know, practice is just kind of, this is probably the most efficient way.
Yeah, they do that.
So first 2 groups, come in, take your cups. You should recognize which ones are yours because they're the ones without the bubbles. We're gonna do one more of these for the next 2 groups. But let's go ahead and take out yours. Where's the other group? Oh, he's doing it. Okay. You can see like 2 of the. If you guys want to come in here and look, for example, go ahead and show them like how the bubbles before, where it's like foaming. Now it's clear, right? So, and then these 2 still have a little bit more bubbles that we need to get rid of. So we're gonna do it for one more cycle of this, and then we'll be done with this setup. So just go ahead. Have one person maybe hold the mass, the other person like just gently pour and spread it out evenly everywhere. Use, do you guys still have your, or not? But go ahead and like just like kind of like pour it over. Try to be as slow as possible to not introduce more bubbles to the system, and try to like spread it evenly across all the surface. Once you accomplish that, place it on any one of these hot plates. If you're gonna do on this one, put it on like one of the corners just so there's room for another wafer, okay? So for the other 2 groups, you got about 2 more minutes and then we're gonna take it out of there and it should be set.
stuff underneath the.
This? Okay. Okay. All right, so set your timer, 10 minutes. That thing should be ready, and then you,
10 minutes?
yeah, and then you guys can use these little pen knives and cut out the pieces for you guys if you want. You can take it home, show it to your friends, be like, look at what I made. It's so awesome.
With 2 wafers that on there?
Yeah, 2 wafers should be able to fit on there. So actually move that to the corner a little bit so maybe you could fit another one. You could probably start taking the little tweezers, poking at it, see if it starts solidifying or not, okay? Yeah.
Safety first.
Yeah, it's gonna like splash back at you like flubber. Flubber? Kind of solid? Okay, give it like another, that minute and then it should be good, right? You're probably gonna have to cut it out of the ring because it's gonna stick to it, so.
You want us to take the wafer off?
Yeah.
Yeah.
So, yeah, go ahead. So you guys can go ahead, take the wafer off. Use probably the gloves. It's not that hot to be honest, but just kind of slide it off. Stuck to it? Or hang on. All right.
Can you grab it by hand?
Okay, no. Give me, hang on. Yeah, like. Okay. So a little. All right, so a little trick. When you guys are ready to take it off, grab some paper towels. A little bit hot. The gloves will also help too, just more insulation, and then push it off the edge and then use the paper towel to cushion it, and then let it sit for a little bit because it is kind of hot. So, all right. So go ahead and be careful with the X-Acto knife. It is extremely sharp, and then it's going to be kind of. So.
Okay, you was a brave soul.
Just,
Watch out! Is your legs okay?
Don't worry about the wafer underneath. It is a silicone, so if you scratch it, it'll probably break. But it is a waste one. We don't need it. We don't use it anymore. But you can start. Yeah, you can start with the outside, and then you can go ahead and just carve out the sections for your group, so they can show off to their friends. It's amazing.
Precise to nanometer level.
Oh, and I would suggest when you try to pry it off, it's still kind of sticky, so use this instead, because otherwise you might just pluck the knife into your eyes or something. But like cut it all the way around if you haven't already. And just like stick it in there, ram it in, be rough with it. It should be fine.
Get the both underneath.
Yeah, get both of them if you can, but okay, that works too. So.
Later, you just have to start adding so many, so you get to this point in the formulas, so like now you gotta get that and check while you're beginning. And you don't want it all again. So you have like a file and
Yeah.
So bring that rope inside.
That's fine. I mean, the features aren't there, so. And then you can use those X-Acto knives to cut the pieces up for your, what? I mean, you can take them home. They're perfectly safe. They're biocompatible, everything. So,
Cutting board.
oh, cutting board. Well, let's go ahead and use that.
I mean, I don't want to ruin a nice desk for Does it matter which side I cut it on? Does it matter which side I cut it on?
It doesn't matter. You're cutting it all the way through. Okay. So, yeah, it's probably ready. Has it been 10 minutes or so?
We put it on like a few minutes.
Okay, so it's probably ready. So go ahead. Just be careful when you take it off. So the best way is to push it towards the edge. Looks like it's sticky.
So that's kind of the closest I can get to Actually, there's really not much in California. I couldn't afford USC. I tried to
That's how I memorize names. Like,
So for this, you can go ahead and like cut a circle and then peel it off, like what he did, and then you can decide how you want to like divvy it up for your friends. If you want to cut, this way, like the patterns, So yeah. So you guys can decide who wants like the most features, and then I don't know how you guys are gonna divvy it up, but. Oh, when you're trying to peel it off, don't use a knife, please. He has a tweezers. Just no, cut it first. Cut it all the way around. Where's the? Oh, can you get the tweezer? And I think that's it. So, yeah, take your trophies and